Okay, so this is from 3-2. In 3-2, you're graphing polynomials of higher degree. They could be any kind of polynomial. So you can get an x to the third, an x to the fourth, an x to the fifth, whatever it is that's there, okay? You start first by identifying your end behavior, and you do that by putting your function in order of decreasing degree, which this one already is. If it wasn't, I would rearrange it. I identify the degree, which is the one with the highest exponent, and the degree here is 4. Because that's even, both my arrows are pointing in the same direction, either both up or both down. Then because it's positive on the front, that means they're both up. So the end behavior is both up, or rising left, rising right. God bless you. Then you have to find your zeros. So I change y, or if it was f of x, I change that to 0. And at this point, these are going to be factorable, okay? When we get further, you'll find that they are not all factorable, but at this point, they are. I can take an x out from the beginning. So I get x, and then x to the third, plus 2x squared, plus 5x, plus 10. And then I can factor by grouping because there's 4 terms. So the x is still in the front. From the first set of parentheses, I can take it an x squared, and I get x plus 2. Second set of parentheses, I take it a 5, and I get x plus 2. And then the x plus 2 is my greatest common factor, and the x squared plus 5 gets grouped together. I can't factor the x squared plus 5 because it's not a difference, 2 squares, it's a sum, and it's not even both perfect squares. So at that point, I'm done with the factoring part. Now I split and solve. So each of these gets set equal to 0. X equals 0, that's one of my x-intercepts. X equals negative 2, that's another one. X squared would equal negative 5, and when you go to square root it, it would be an imaginary number, which does not appear on the graph. So that's as far as it goes.
Can you take out an x squared in the beginning?
Yeah, I did. But you can't get rid of it. You got to set it equal to 0. So then the multiplicity is how many times these occur. This is only once, which means it's going to cross through at each of these. So I go to negative 2, I plot a point. I go to 0, I plot a point. Both my arrows point up. And it crosses through both. So it's coming down and going back up. I don't know how low yet. The next thing I would want to find, so these are my zeros or my solutions or my roots. Those all mean the same thing. My y-intercept would come from plugging 0 in for y, but I already have it. It's 0. Because if your x-intercept is 0, your y-intercept is 0. So that doesn't help at all. I need to plug in something else to figure out how low it goes. So I'm going to plug in from in between the negative 2 and the 0. I'm going to plug in negative 1. So if x is negative 1, I'd get y equals negative 1 to the fourth plus 2 times negative 1 to the third plus 5 times negative 1 squared plus 10 times negative 1. So 1 plus 2 times negative 1 plus 5 times 1 minus 10. And I get negative 6. So when x is negative 1, y is negative 6. I go down to negative 6, and I know it goes down and comes back up. And it might go down a little bit further than that. This is just an approximation. As long as I know, as long as I've plugged in a point from each bound, like each time it goes down and comes back up again or up and down again, I need to know how high it goes. At least 1 point should be plotted there. How low? Yep. So on the review, there's a bunch of different examples. There's x to the thirds, there's x to the fourths, whatever it is, they are there, okay? There's ones in which they're already factored. We did those in the notes, like if it said x plus 1 to the third or something like that, which if we can get to it, they're on the end of this. But all of that's on the review. I would say make sure you're prepared for any kind of graphing based on any kind of factoring because it's going to be different. All right, then came 3-3, and this was your long and synthetic division. So you will get questions that just say divide using long division or synthetic division. Remember that if it's squared, what you're dividing by is squared, you cannot use synthetic. If it wasn't, if that just said x plus 1, I could choose. And obviously, I would recommend synthetic. But you're going to be forced to do one of each. And then you've got the application of the synthetic division, like number 2. So with number 1, you have to use long division. The numerator is not in order, so I would first put it in order. It would be 2x to the third minus 8x squared plus 3x minus 9. If there was anything missing, I would plug it in. As far as exponent goes, there's not. On the divisor, however, you've got an x squared, but you don't have an x. So 0x goes in there, which means I'm dividing by x squared plus 0x plus 1. And then we start first into first. So to multiply x squared by something to get to 2x to the third, it would be 2x. And I would multiply it times the x squared. I'd get 2x to the third. Multiply it times the 0x. I get 0x squared. Multiply it times the 1. I get 2x. Sophia. I multiplied 2x by 0x. Then we change our signs. These cancel. 8x squared minus 0x squared would be negative 8x squared. Positive 3x and negative 2x is positive x. And I bring down the 9, negative 9. And I repeat the process. So first into first again. X squared to get to negative 8x squared is a negative 8. And I multiply it times x squared, so negative 8x squared. I multiply it times 0x, so 0x, and it doesn't matter if it's positive or negative because it's 0. And then negative 8 times positive 1, negative 8. And we change our signs. These cancel. Positive x minus 0x is x. Negative 9 plus 8 is minus 1. This is my remainder. And this is my quotient. And I write it as quotient plus remainder over divisor. Number 2 is use synthetic division to show that negative 4 is a solution, spelled incorrectly, but still a solution, to f of x equals x to the third minus 37x minus 84. Then find all the factors or zeros. So the first part of this is telling you negative 4 is a solution, which means I'm going to put negative 4 on the outside. If it had said x minus 4 is a factor, now I change the sign, but if it just gives you the answer or it says x equals negative 4, we keep the sign the way it is. Then I'm going to use synthetic division. I've got an x to the third, that's 1. I'm missing an x squared, so that would be a 0. I've got an x which is negative 37, and I've got the constant which is negative 84. I bring down the 1. I multiply it times negative 4, put it in the next column, and add it. Multiply it, put it in the next column, and add it. Multiply it and put it in the next column, and add it. If you don't get 0 there, you did something wrong because it's telling you it is a root or an answer or a solution or a factor, which means it has to have a remainder of 0. And then I'm going to take what's left of my divisor. So that's my remainder. The 21 stays because that's the constant. The 4 gets the x. The 1 would get the x squared. So I have x squared minus 4x minus 21. Set it equal to 0 and factor it. So x minus 7 and x plus 3. Split and solve. and I get the remaining factors. It says find all the factors. So I include in my answer the one they gave me, -4, then -3, then +7. The other thing from this section that is on your test, which obviously is not on this, is when you use the remainder theorem to find like f of 2. So we put 2 on the outside and we find the remainder, and that's the answer. That's also on your test.
Why do you put in a 0 when you're doing it?
Because there's no x squared. So it's still the same rules apply. It has to be in order of decreasing degree, and there has to be a term there for each one. All right, so it says use synthetic to divide. So what goes on the outside is the opposite of the +12, so it's -12 on the outside. And then I look at my function, I'm missing an x squared, so the 0x squared is going to go in that place. -1 is in front of the x to the third, 0 is in front of the x squared, 121 in front of the x, and -276 is by itself. Bring down the -1, multiply by -12, put it in the next column and add it. Multiply by -12, -23, and then I'm going to multiply -12 by -23. $276, and it's positive, so the remainder is 0. So then the 12 gets the x, and the 1 gets the x squared. So -x squared plus 12x minus 23, remainder 0 is your quotient. This one says use synthetic division to show that x is the solution. So if 1/2 is the solution, I keep it as 1/2. And then I list all the coefficients. So 2, -15, 27, -10. Bring down the 2. Multiply it by 1/2, that's 1. Add it, it's -14. Multiply it by 1/2, that's -7. Add it, that's 20. Multiply it by 1/2, that's 10, and the remainder is 0. Again, if you don't get a remainder of 0, something's wrong. So the fact that that's there is good. This gets the x, this gets the x squared. So 2x squared minus 14x plus 20. I would set it equal to 0 and factor it. I can actually take out a 2 this time. Make my life easier, because if you divide by 2, it's gone. 0 equals x squared minus 7x plus 10. And the factors of +10 that sum to -7 are -2 and -5. And then split and solve. And my 3 zeros, because you have to include the one they gave you, are 1/2, 2, and 5. And then this is 10. Use synthetic division to show x is the solution of the third degree polynomial. So this is the same kind of question as the last one. Because it's x equals -6, the negative stays on the 6 on the outside. And then this would be a 1x to the third. There's no x squared, so 0, -52, -96. Bring down the 1. Multiply, put it in the next column. Add it. Multiply it, put it in the next column. -16, multiply it, put it in the next column, +96, remainder 0. Again, that should be a remainder 0 or something's wrong. -6 gets the x, 1 gets the x squared, and then factor it. Factors of -16 that sum to -6 would be -8, +2, split and solve, and I get x equals 8 and x equals -2. So my 3 answers, because again you need all 3, are the one they gave me, -6, and then -2, and then +8. So on the review, okay, which this is obvious, I posted, I think the answers are there too. This first section is all the 3-1 stuff. So this is all the quadratic, the parabolas, okay? And it doesn't say specifically how to solve them. It says to use the vertex axis symmetry, x and y intercepts to graph the function. You will be asked like parts. And just like before, it's going to also ask you for domain and range. I think, actually, now I'm starting to question myself. Can't remember if that's on the review or the test. I'll check. But some of these are in standard form already. Some of them are not. And on the ones that are not, you can choose whether you want to do the negative b over 2a or you want to get them into standard form by completing the square. There is going to be one question that says to get it into standard form by completing the square. So you want to make sure that's why I wrote on here at least one of these practice the complete the square. You also have the ones from your quiz. So if you wanted to practice those, that wouldn't be the worst idea, okay? Then this is the synthetic and long division. This all came from, so it's a little out of order. This came from 3-3, which is what we just finished on Friday. This is also 3-3, just like the one we just did, where you take the 0 that they give you, put it on the outside, reduce it the degree, and then factor it. And then a bunch of examples on the graphing from 3-2. It says use the leading coefficient test to determine the end behavior. Find all the zeros with the multiplicity. Figure out if that means it bounces or crosses through. Find the y-intercept and then graph the function. That goes to 14. And then at 15, this is back from 3.1, which was find the equation of the parabola in standard form, y equals a x minus h squared plus k, when you're given the vertex and the point. Also from your quiz. I would say feedback from quiz is overall pretty good. Couple mistakes on this part. People forgot the squared. Don't forget the squared. They either forgot it before they even started the work or they forgot it when they rewrote the answer at the end. Be careful there. They forgot the y equals, that kind of stuff. And then as far as the parabolas went, like the overall were pretty good. Silly mistakes made here or there with like the fractions, okay? And if you did not do well on the complete the square part, make sure you review that part. Okay. 9 said use synthetic division to show that it's a solution to the third degree polynomial and use the result to factor. So because it's telling you what x equals, I leave it alone. 1/3 goes to the outside. 3, negative 16, 23, and negative 6. Bring down the 3. Multiply by 1/3, that's 1. Add, that's negative 15. Multiply by 1/3, that's negative 5. Add, that's 18. Multiply by 1/3, that's 6, and it's 0. If it's not 0, something's wrong because it's telling you that it is a factor. So now I need to take what's left. I give this the x squared. 3x squared minus 15x plus 18. And I want to factor by grouping. I actually can take out a 3. Make my life a little bit easier. X squared minus 5x plus 6. And then it's 3x minus 2x minus 3. And then I get 2 and 3. So the 1/3 that they gave you and the 2 and the 3 are all zeros. Cool.
Is it possible where it's not factorable at all? The only answer
It is possible, but not on this test. Like that's what we're going to learn in 3-4. What happens if it's not factorable? Yours will be factorable for the test. Kylie.
So since the 3 on the outside and then the 3 that you finished with, since there's like 2 of those, you just like.
This is not a 0. There's no x there. So that one doesn't even count. I could divide by 3 and it goes away.
Okay, so
The only thing that matters like that is if you take out a variable. If you take out an x, you can't get rid of it. But if you take out a solid number, then it doesn't count. Okay, so then negative 6 was on the outside of this one. You're missing an x to the second. So it would be 1, 0, negative 63, and negative 162. Bring down the 1. Multiply it. Add it. Multiply it. Add it. What's it? 7. Negative 27. Multiply it. 627. Negative, positive 162. There's my 0. Again, if it wasn't 0, something's wrong. So then I take what's left. This gets the x. This gets the x squared. And factor it. Factors of negative 7 that sum to negative 6 would be negative 9, positive 3, split and solve. X is 9 and X is negative 3. So then it's the negative 6 that they gave you, the 9 and the negative 3. You're welcome. I had one more question. This was 2 from the homework. So long division, again, you want to make sure it's in order, decreasing degree, nothing's missing, which both are fine. The 2x plus 5 goes on the outside. 2x to the third minus 11x squared minus 38x plus 5. And first into first. So I have to multiply by x squared here. It gets multiplied. X to the third. 5x squared. Change the signs. Negative 16x squared. Bring down the minus 38x. This would be negative 8x. Multiply it times both. Did you find your mistake?
16 divided by 2 is 9.
Change your signs. This would be 2x. Bring down the 5. And that's 1.
What do these little things here do?
That just means it couldn't be, that's your restriction. That's like your domain, because if it's divided by, that thing would be in the bottom. And 2x plus 5 in the bottom would mean x can't equal, that's just a restriction. It doesn't change anything of what you do. Yeah.
Wait.
This, it would say f of x equals, and again, there's going to be 2 different ones. One in which you're actually graphing this, and then one in which it just says to solve it. If it just says graph it, you don't have to complete the square. You can do negative b over 2a, whatever you're comfortable with. But the one that says put it into standard form, that's when you have to complete the square. So I would start by grouping the first 2 together. Take the 2 out. When you take it out, you're dividing both these terms by it. So it's x squared plus 3 halves x. Leave the space, plus 2. Now I take the 3 halves, divide it by 2 and square it. Dividing by 2 is the same as multiplying by a half. So I get 3/4 squared, which is 9/16. I add it inside the parentheses and I subtract it from outside the parentheses. But if you take something out, you have to multiply it by that first before you add it or subtract it. So then 2 goes into 16 8 times, and I'm subtracting 9/8. 2 stays on the front. Factor this by square rooting the first term, square rooting the last term, taking the sign from the middle, putting it in parentheses and squaring it. And then positive 2 minus 9/8 would be 16/8 minus 9/8, which is 7/8. And that is your standard form. From here, my vertex is the opposite of what follows x and what follows the parentheses. My axis of symmetry is x equals the x coordinate. My domain is all real numbers. This opens up because this is positive. So my range is the k to positive infinity. My y-intercept is easiest to determine from the beginning when it's in quadratic form. It doesn't work when it's in standard form, but when it's in quadratic form, it's just the 2. If I had to get it from here, you'd have to plug zeros in for the x, which you're going to have to do because there's one in standard form. And then to get my x-intercepts, first I would graph it. Negative 3/4 and 7/8 is like this. My y-intercept is 2. This points up. If it points up and doesn't touch the x-axis, there are no x-intercepts. If it pointed down, let's say, or it crosses through there, I would probably use quadratic from here. You can also use even root from the standard form. If they were whole numbers, maybe I would do that. But I would do quadratic from the beginning to get the intercepts.
If it did go through the x-axis, then you'd have to set the original equation to 0.
Yep. And then I would use quadratic formula. Yep. Unless it was like in standard form. Like if it's something easy, like one of the ones on the review, let's say it says that, right? Then I could add the 10, divide by 2, square root both sides. You could do the even root that way.